Hey everyone, today we are going to solve the daily LeetCode challenge of 3rd March 2024 and the problem statement is remove nth node from end of list. So let us first understand the problem statement. So according to the problem statement, we have been given a linked list and an integer n. And what we have to do is we have to remove this nth node from the end of the linked list. Okay. So here the value of n is 2. So if we start from the end, then this is the first node and this is the second node. So it means that we have to remove this 4 from the linked list and then return the new resultant linked list. So if we remove this 4, what we will get? We'll get 1, 2, 3 and 5 because we have removed this 4. Now the question is that we have been asked to remove the nth node from end, right? So do we have the access of the end node? The answer is no. We only have the access of the head node. That is this 1. We have been given only the address of this 1. Additionally, we all know that in case of singly linked list, we can only move forward. That is, we can go from this 1 to 2, from this 2 to 3, from this 3 to 4, and from this 4 to 5. We cannot move in the backward direction. That is, from 5 to 4, we can't move. Why? Because for every node, they have only a next pointer, which points to its next element. Correct? So it means that we cannot find this nth node from the end. So what we need to do is we need to find that what is the position of this nth node from the start. Okay. So here we can see that 4 is this particular node 4 is the second node from the end, right? So what is its position from the start? If we will find its start position, then what it would be? It would be nothing but the length of this particular linked list. So what is the length? The length of the linked list is 5. So it would be length minus n. So it will give us 5 minus 2, which is 3. And you can see that if this is the 0th node, this is the first, this is the second, this is the third. Then what is the position of this particular node which we want to delete? It is nothing but 3. Correct? Now that we have understood that what is the position of this particular node from the start, so what we can do, we can simply start iterating from the first node and then we can easily delete this particular node, which is 4. Now one more thing you should keep in mind is that whenever we want to delete a node, let's say here we want to delete 4. Okay, so how are we going to delete this? So I am having 1, 2, 3, 4, 5 and we want to delete this 4. So what we will do? We'll simply set the next of 3 as 5. So what will happen? This link will get broken and this link will also get broken, right? So automatically this particular 4 will get removed and we'll get a linked list as 1, 2, 3, 5. Correct? So what does it mean? It means that, so if we want to delete this node 4, where should we stand? We should stand at this particular node 3. Then only we will be able to delete this 4, right? Because if we are at 3, then we'll just simply set the next of 3 as 5. That is, say for example, if 3 is current, so we will set currents next as, we'll set currents next as currents next, correct? Currents next, right? So this is how we'll be removing this 4. So we have come up with 2 points. First is that we need to find out the start position, right? We need to find out the position of nth node from start, right? We have to find out the position of nth nodes from start. And for finding the position of nth node from start, what do we require? We require the length of the linked list. So we also need to find the length of linked list, correct? And one more thing is that up to which point we need to go? We need to go one node prior to the node we want to delete. That is, here we wanted to delete this 4. So we have to come up to one node prior to it. Then only we will be able to delete it, right? So we have to go we have to go one node prior to node to be deleted, correct? Now, there is one more scenario which I want to discuss. Say, for example, if this is my linked list 1, 2, 3, 4, and the value of n is 4. Okay. So here we want to delete the fourth node from the n. So what is the fourth node from the n? This is the first node, this is the second node, this is the third node, and this is the fourth node, correct? So 1 is the fourth node from the end. So in case when my length of the linked list, in this case, the length of the linked list would be 4. So in the case when my length of the linked list is equal to the value of n, what we will do? We will simply return heads next. In this case, our head is pointing at 1, right? So what we will return? We will return the next of head, which would be nothing but 2, 3, 4. And what we were supposed to delete? We were supposed to delete the nth node only from the end, right? And the nth node from end is what? It's 1. So we have, if we are going to return the next of head, so it would be this, right? So eventually we have removed this one, correct? So this is how we are going to solve this problem. Now let's quickly code this. So first of all, we'll have to find the length of the linked list. So let's write the function find length, and we'll be passing on the head. Okay. And what we discussed over here, we discussed that if length is equal to n, in that case, what we'll do? We'll simply return heads next. Fine. Otherwise, if the value of n is not equal to length, then what we need to find is, we need to find this position, right? This start position. Correct. We need to find this start position. So the start position was nothing but length minus n, correct? And here what we discussed, that we have to go one node prior to the node to be deleted, right? So since we have to go one node prior to the node to be deleted, so for that reason, we have to subtract a 1 from this, okay? So let's take a node as, and let's call it as current. It would be equal to head. And what we will do, while we have start position, what we'll do, we'll simply increment our current pointer, right? We'll simply increment current. So we'll say current is equal to currents next. Fine. Now, once we have come to this node, let's say in this case, we were supposed to delete this 4, right? So once we have reached to this 3, what we have to do is, once we have reached to this 3, we have to set its next to 5, correct? So what we'll do here, we'll set currents next as currents next, right? And at the end, what we'll return? We'll simply return the head. Now we have to complete this function find length. So this find length would return us an integer value, which would be the length. Here we'll pass the head node. And let's take list node current as head. Let's take an integer length initially as 0. And now we'll iterate until my current is not null. So what we'll do, we'll set current as currents next, and we'll increment n. We'll increment the length, right? And what we have to return? We have to return the length from here. And now let's run this. So it's giving us the correct answer. Let's submit it. So it got accepted. Talking about the time complexity and space complexity. So the time complexity would be order of m, where m is the length of the linked list. So here you can see that in the find length function, what we are doing is we are iterating over the complete linked list, right? So say for example, if this is our linked list and its length is m, then here we are taking a time complexity of order of m to iterate over each of the node of the linked list to find its length, right? So that's the reason why the time complexity is order of m. And since we are not using any extra space complexity from our side, so the space complexity would be order of n, order of 1. So that's all about today's daily LeetCode challenge. Thank you.